In this video, I'm going to do a simple walkthrough of the mass balance system so you've got an understanding of what it actually is. Now, it's obviously a mass balance system connected to a flow sheet. So we'll start off by having a look at the flow sheet. Now I've done a very simple flow sheet which explains a number of the key concepts. Now, the icons are available in the course, and these icons are originally available from David Wiseman. So we set it up so that there's a canvas, and this is an unusual feature. But everything goes into this canvas so that if we move the canvas, the flow sheet moves. And these icons are connected. So if I move one, the stream will follow. These are streams, these are units. Now, this is obviously the feed to the comminution circuit. And if you look, it says here feed. So you give each stream a name, you give each unit a name. And this shape here, which I've called a passive join, and I understand that would be hard for you to read, but I'm telling you that's what it's called, passive join. That's there only because Excel isn't necessarily a sophisticated flow sheet system. Now, I started off by using Visio, Microsoft Visio. I believe Microsoft has really done a poor job of Visio, and not many mineral processors use it, even though I think it's potentially useful. But these flow sheets could be constructed in Visio and the streams could go all the way round rather than having this join. But this join is purely there for the reason of being able to enable that complete U-shape. It has no major effect on the mass balance. So this is a flow sheet. It has 1, 2, 3, 4, 5 streams. So what we do is we use templates. Now, I'm actually not going to do too much running of the code here because I'm limited to 10 minutes. But basically we have a stream template. So this is where we put all the effort into designing the data structure that will be balanced. Now, this balance in the course is 1D only, and consider it a trial version, whereas the full 2D mass balance would be negotiated separately. And of course it can go to higher levels than 2D. So you put your effort into constructing this template, and if you're just going to use it for size, you simply, and it's different size classes, you simply type them here and you really cut rows you don't need or insert rows you do need. That's all you need to do. Now, obviously I'm using color styles. They mean something, so keep the same color styles. I'm not going to focus too much on color styles here, cell styles. And if we look, I also use name ranges. So this whole template is called Mass 1D Stream. This here represents Mass 1D Stream.experimental. This is 1D Stream.experimental.size, and so forth. These name ranges are used directly by the VBA code, and if you were to get rid of them, the mass balance won't work. Now, there's some columns here which really aren't used that much. So balanced SD is not used. Now, there's an issue with least squares versus information theory. I tend to use information theory, but there is capability of using least squares. But the most important thing to set is this, the confidence. How confident are you in the data? Is it missing, or is it just your standard measurement, or is it in fact unused? Do you have low confidence or high confidence? Now, this is a strategy which I developed originally with JK Tech for their systems. So it means you don't have to worry about focusing too much on standard deviation. Similarly, there's a unit template, which I won't explain here, but all the units use the same template. All the streams use this same template. We have two ribbon commands here. One is this FN, which means flowsheet analysis, and then we have the mass balance system. Now, because in my original concept of using this flowsheet system, it wasn't limited to mass balancing. So there's a number of different applications which use the flowsheet system. So that's why it's a separate ribbon. So we go to the flowsheet analysis, we set the flowsheet, and then we process it. And by processing it, we determine which stream is connected to which unit. And then in this name, we say what the templates are and where the data's going. That's all. So we're not going to do a complete walkthrough of the whole ribbon system. Then we go to the mass and we transfer all that flotation analysis data to the mass balance system. So it knows where the templates are, the units are, and where you want to put the data. We now create the flow sheets. Basically, these are the options for mass balancing. The dimension 1D, because it's size, and specify that it's size. And there's a list of applications we can use. And the first one is mass tables. I'm not going to run it, but if we do run it, it creates all the streams and all the units. And it's basically copied the templates to create these units. And what is another unique capability is the fact that I've transferred the name ranges, but I start off with the name of the unit, but I start also with mass, indicating it's for mass balancing. Now, this is the mass balance component. Later, you want to do simulation. So again, flowsheet analysis, and this data is used for simulation. We're not discussing that here. So if we return to the mass balance system, we've created the tables, then you have to obviously put in the experimental data. As I alluded to in the PowerPoint, you can automate that, which these buttons retrieve data. Again, we're not going through that here. And you can store the data as well once it's created. The whole issue of automation is relevant, but outside the scope of this immediate discussion. Now, when I create the tables, there's two steps. There's initialization and run. So the initialization is setting it up. It's calling up the VBA code effectively, and any initialization is performed, and then we run it. And that goes for all of these. So tables creates it. Here it's already been balanced, but I'm saying I don't want the water balanced, so these water flows and percent solids aren't used. Total flow is not used, although it's putting a value there which you ignore. And if I were to change these values, when I run the balance, it will updo it. It will re-estimate those values. So the next step is you actually load the data. So the data's here, we load it. Again, initialize, run, and then we do an initial mass balance. Now, this is a little bit odd, but basically I have two algorithms for the mass balancing. This final one is more leaning towards least squares minimization, whereas this is a fast method using information theory. The problem here is the fact that there's very little benefit in this later step, and I still keep it because I know some people want to use a least squares approach. That's a complicated technical discussion, which we won't go into here. So for most people, you just run this initial mass balance. You don't actually see the balanced results. You then have to unload the results, which puts them out here. And really, that's all I wanted to say. I think that covers the process. As you can see, it's not that hard. I do explain before that the person who sets up the template is like your designer and sets up the flowsheet is your designer. But once they're set up, you simply follow about 8 different steps. They're quite straightforward. If you do have problems, you write to me. because I want to see that you're happy. And if you do have test cases, I'll may or may not include them in further lectures. So that's the walkthrough of the software.